So in this video, I'll be going through the 2018 Higher Paper 1. So let's make a start. Question 1 has given us some mixed numbers and it's asked us to work out how we add them two together. So the first thing is we're going to multiply 2 by 7 and then we're going to add the result with the top. So 2 times 7 is 14 and we're going to add the 1 which is 15 and divide that by 7. For the next one, we're going to do the same thing. We're going to do 1 times 4, which is 4, and then we're going to add the 1 at the top. So that will be 4 plus 1, which is 5. So that will be 5 over the same denominator. Now, with fractions, you have to make the denominator the same. So we're going to times the top and bottom by 4 here, and we're going to times the top and bottom by 7 here. And that becomes 4 times 7, which is 60. Divide that by 28, plus 7 times 5, which is 35. Divide that by 28, which then equals 95 over 28. So the next question is dividing two fractions. So with this, you want to remember the KCF method. So that's keep, change, flip. So with the first one, we do 1 times 5 and add the top number. So that will be plus 1. So that will be 6 over 5 times and flip the last fraction with the KCF method, which is 4 over 3. So then we have 6 times 4, which is 24. We then divide that by 5 times 3, which is 15, which gives us 8 over 5. Now it says give your answer as mixed numbers in its simplest form. So we've put it in its simplest form. Now we just need to write in mixed numbers. So how many times does 5 go into 8? It goes in 1 times with a remainder of 3. So the denominator stays the same as 5. The number at the top goes out here, and the remainder comes in here. So the answer is 1, 3 over 5. Moving on to question 2. In a village, the number of houses and the number of flats are in the ratio 2 to 7. The number of flats and the number of bungalows are in the ratio 8 to 5. There are 50 bungalows in the village. How many houses are there in the village? So we have houses to flats in the ratio of 7 to 4. And then we have flats to bungalows in the ratio of 8 to 5. And they have told us there are 50 bungalows right here. I'll use a different color for this bit. So there's 50 bungalows. Well, how do I go from 5 to 50? I times it by 10. So how do I go from 8? So I'll do the same thing on the left side. We do 8 times 10, which is 80. So but now we know there are 80 flats. So we come over here. We know there's 80 flats. Well, how did I go from 4 to 80? Well, I must have times it by 2 because 4 times 2 is 8. We add a 0 on. That gives us the 80. Do the same on this side. So that means there are 140 houses. Question 3. Reen buys 5 kg of sweets to sell. She pays £10 for the sweets. Reen puts all these sweets in a bag. She puts 250 grams of sweets in each bag. She sells each bag of sweets for 65p. Reen sells all the bags of sweets, work out a profit. So just to make the units consistent, 5 kg can be written as, let me just change the color on my pen, 5 kg can be written as 5,000 grams. We know that she puts 250 grams of sweets in each bag, so we can do the total amount of sweets she buys. She puts 250 grams in each bag. Now we can write that here as 5,000 divided by 250. The zeros can cancel out. We know 25 times 2 is 50. We add a 0 on, so it must be 20. Right, so she's got 20 bags altogether. We know she sells each bag for 65p. So we can do that right here. We can hop the decimal out twice and then hop it back in. So if you hop the decimal out twice, we can then do 20 times 65. And when we get the answer, we can hop the decimal back in. So the way we can do that is 20 times 65. That's 0 and 0. That's 10, that's 12, and that's 13. That's 1300. So the answer here is 1300. But we now need to hop the decimal back in twice. So that will become 13 here because we hopped it out. So she makes £13 altogether. What is her profit? So we know she paid £10 to buy these. So she's made a £3 profit, but they want that as a percentage. So that will be the total, which she paid, which is £10 divided by the profit. And we can times that by 100. So that will be 30%. Moving on to question 4. A cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous race is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. Estimate how many hours Juan will take to complete this race. So the nice bit here is they've told us to estimate. It is a non-calculator paper, so we can remember that the equation speed is equal to distance over time. They have told us the distance is 3,000 miles because I'm rounding it to make my life easier, because if they've asked me to only estimate it. The average speed is 15.12, so I can round that again. So the speed can become 15 miles per hour. He will cycle for 8 hours per day. So in terms of time, it's 8 hours per day. So we can substitute the speed and the distance into the equation to work out the time. So this isn't necessarily speaking the time because that's how many hours he cycles per day. We need to work out the total time. So this equation then becomes distance is equal to speed. Sorry, not distance. Time is equal to distance over speed, which is 3,000 divided by 15. We know that 15 times 2 is 30, and we add 2 more zeros on, so that's 200 hours it will take him altogether. But we know he's only cycling for 8 hours per day, so you can do some division here. So 8 times 2 is 16, it leaves me with 4, bring that 0 down, so that is 25 days. So it will take him 25 days to complete the race. So moving on to part B, John trains for the race. The average speed he can cycle increases. Okay, so now he's cycling a little bit faster. How does this affect the answer to part A? Well, if he's cycling a little bit faster, if you come back and look at this equation, that means that number's now gone up. If that number's gone up, that means this value here has gone down. So it takes him less hours and hence less days. So we can say it will take him less hours in total and hence less days to complete the race. So moving on to question 5, here's a solid square-based pyramid. So notice it's square-based, which means on a square all sides are the same. The base of the pyramid is a square of 6 centimeters. The height of the pyramid is 4 centimeters. M is a point of BC. It's a midpoint of BC, and VM is 5 centimeters. Okay. Draw an accurate front elevation of the pyramid. So the front elevation here, if I just use my highlighter, that would be this. This is where the arrow is pointing. It's going to be that there. And that's this arrow here. That's pointing there. So if I now go down onto here, I know the base of what it's pointing at is 6 centimeters. So if I go 6 across, and I know the height is 4, and that's that number there. I'm going to rub that off for now. So it's going to go up 4 from the middle, so that would be somewhere there. And we can join the points together. Of course, draw these on the lines accurately using a pencil and a ruler. It will look something like that. Part B, work out the total surface area of the pyramid. So the surface area is just all the outside faces. So we can start with the bottom. So if I just again use my highlighter and I use a green one, so the bottom is going to be that. There. It's going to be this square at the bottom, just to make it clear. I'll put that there. So if you write that here, I'll use that color as well. So that's going to be A, B, C, D. So that is going to be 6 times 6, which is 36 centimeters squared. And remember, it's a square, so all sides are the same. And now I need to work out all the other faces. So there's 4 faces left now. And again, if I use my highlighter, I've already highlighted one of them. The other one would be this one that's coming down here and going across like that. The other one will be one that's behind there. So across like that and that. And the final one will be one that sits there and there. So I just need to work out one of them and times it by 4 because they're all the same. So if I just quickly draw out here one of the faces, well actually we've sketched it out down here, so that's one of the faces, and you can see one of these faces, the base is 6 and the height is 4. But now careful here, this is the elevation on how we see it. Now the height really isn't 4, the height is this slanted height 5. I've mentioned this on purpose because this is where people make a mistake. They just do 4 times 6 and divide it by 2. Whereas if you would actually draw out V, for example, VCB, if I draw that out, and we have V, and we have C, and we have B, it could be any of them faces, they're all the same. Now, yes, the base is 6, but this height here is 5. We're using the slanted height. It's the face of the triangle. So in this case, VBC is going to be 5 times 6, and we're going to divide it by 2 because it's a triangle. 5 times 6 is 30, divided by 2 is 15. Now we know there's 4 of these faces, so we can times that by 4, and that's 60 altogether. And now the total area, I'll use a different color for this, is going to be 36 for the bottom, plus all the other 4 faces, which then gives me 96 centimeters squared. Moving on to question 6. A pattern is made from 4 identical squares. Again, squares means all sides are the same. The sides of the square are parallel to the axis. Okay. Point A has the coordinate 6, 7. Point B has the coordinate 38, 36. Point C is marked on the diagram. Work out the coordinates of point C. So the way I would approach this question, they're all squares. If I can work out the side of one of these squares, that can help me solve this question. So the distance from here to here, remember coordinates are x, y. So I know right here it's 38, and I know right here it's 6 in terms of x. So this coordinate, that there, and that there. I can subtract the 2, so I can do 38 minus 36, which gives me 32. So I know now the total length of 4 squares is 32. So that would be 32 centimeters. Now to work out the length of one square, I can divide that by 4. So I can do 32, divide that by 4, and that gives me 8 centimeters. So if I was to draw that here, so that means each of these squares looks something like, let me just draw that a little bit better. That means each of these squares looks something like 8, 8. So if I now come back up here and use a slightly different color, that means to get to C, from this point A, I need to go across by 1, which means I need to add 8, because each square, remember the base and the height of the square is 8, and then I need to add 8 again. So if I come down here, I know x at A is 6, and then I need to add 8 and add 8 to get to C, so I'm working out point C. So the x-axis will be 6 plus 8 plus 8. We know 8 plus 8 is 16, and we can add that to 6 to give us 22. And now for y, if I come here, now you might be tempted to think, well, for y it should surely just be plus 8 and then plus 8. Now the problem is, notice where that ends up. That ends up here, whereas we're not there, we're down here. So if you look at this other coordinate, b, if you go down by minus 8, because we're going down now, and you go down again, minus 8, we end up where we need to end up. So to work out the y coordinate, we're going to use point B. So again, down here, we can say y is equal to, so we know x at coordinate B is 38. Sorry, we know y at coordinate B is 36, because we're now looking at the y coordinates, and we're going to subtract 8, and we're going to subtract it again. Again, 8 minus 8 minus 8 is minus 16. Take them 2 away, end you up with 20. So the coordinates are going to be along the corridor, up the stairs. So 22, 20. And always check your answer and see, does that actually make sense? Yeah, because if this is 6, 7, that's 36, 38, 36, and it's a number that sits within that range, that's right. If you got something like 42, 52, that must surely be wrong because that point will be somewhere up here. And the only reason I'm mentioning that is always sense check your answers. Does it actually make sense? So moving on. So it says shape T is reflected in the line x is equal to -1. So forget my pointer out. Here's the x-axis. So if I go to -1, which is right there, and I draw a line where x is -1, it would look something like this. And now I need to know, well, I need to reflect this to give me shape R. So if I start with this point here, I go 1, 2 till the line, so I'll go 1, 2 again. So that means the first coordinate is there. If I do the same with this top one, I go 1, 2, 3. So that means I must go 1, 2, 3 this way. Again, mark the coordinate. And do the same with the last one. So that's this one here. That's 1, 2, 3, 4. So 1, 2, 3, 4. And that coordinate's right here. So I'm going to rub off the guidelines now. So, because they're getting a little bit in the way. But I'll leave my coordinates on. So if I now connect all these together, that, and that is T. Then it says shape R is reflected in the line y is equal to -2. So my y-axis is that one there. It's reflected in the line, let me just use a different color, line y is equal to -2. So in the y-axis, y is equal to -2. We'll go through this. So if I draw a line across, again use a pencil and a ruler. And now I'm going to reflect. In fact, I'm just going to try to draw that a little bit better than that. There we go, perfect. So it's saying shape R is reflected in the line y is equal to -2. So I'm going to fix this as well, just so that's nice. So we're now going to reflect this. I'll draw my guidelines again. 1, 2, 3. So we must go 1, 2, 3. So that first point I'll draw in blue is going to be there. And hopefully you can see you're going to carry that same pattern on and you'll end up with something like this. And that is S. I'll rub off the guidelines as usual. So describe a single transformation that will map T to the shape S. Now, of course, you couldn't have done this without drawing out them two in the first place, so that's why I drew them onto the graph. So it's saying, how do I go from T to S? Well, I can see it's going to be some sort of rotation, so you're going to use your graph paper in the exam, and we can see we're rotating. You can either rotate this way or that way. It doesn't really matter which way you go, because you're rotating by 180 degrees, so we can say it's a rotation by 180 degrees from the point, and here we'll write the x and y-axis coordinates. So if I was to just rub these two off for now, you can see if I was to go down, I'm going down by, if I was to go down from here till there, I've gone down by 6, and if I was to go across, I've gone across by 4. So half of 6 is 3, and half of 4 is 2, so that means it must be that point there. So that's going to be along the corridor, which is -1, and down the stairs in this case, which is -2. The perimeter of a right angled triangle is 72 centimeters. The length of the sides are in the ratio 3, 4, 5. Work out the area of a triangle. Again, this can be a slightly tricky question, but always start with drawing things out if you can. So it's a right angled triangle. I'll draw that out. Awesome. I'll draw in my right angle. So we know the ratio is 3, 4, 5. Now you must be wondering, well, how do I know which one is where? Well, the longest length in a triangle is always the hypotenuse, which is this side. So that must be 5. I'll use a different color, in fact. And the 3 and the 4, it doesn't really matter where you put them for now. So we'll put the 3 there and the 4 there. But the 5 must be in the right place. So the perimeter of this triangle is 72. So let's use these ratios which we have for now. So we have 3 plus 4 plus 5. We know that 4 plus 5 is 9, 9 plus 3 is 12, so this equals to 12. But they've told us the perimeter is 72. So now the question becomes, well, how do I go from 6 to 72? Again, I'll use a slightly different color here because it can make it a little bit easier. Well, to go from here to here, I'm timesing it by 6. So let's times all of these values by 6. So 3 times 6 becomes 18, 4 times 6 becomes 24, and 5 times 6 becomes 30, and all of them add up to 72. So now you know what the actual lengths are. So it's saying work out the area of the rectangle. So the area of a rectangle is base times height divided by 2. So in this case, we can do 3 times 4. Well, we're not going to use 3 and 4, but we're going to use the actual values. So we know 3 becomes 18, the 4 becomes 24, and divide that by 2. And you can do 18 times 24. Again, you can use the longer multiplication method here and do that and divide it by 2, and you'll end up with 216 centimeters squared. Question 9. So we are now looking at indices. So with question 9, we have 36 to the power of a half, which is the same as root 36, which is 6. So two numbers that multiply together to give 36. Anything to the power of 0 is 1. And for this last one, with negative indices, I always like to get rid of the negative. And the way you can do that is just write 1 over whatever the question is. So all I've done now is the negative is gone. So with this, we can write that as 1 over 27 1/3 and squared. They're both the exact same, and I've written it like this for a reason. And then that can be written as cube root. So 27 cube root, and then square it. So what three numbers do I multiply to get 27? So 3 times 3 times 3. So that's 1 over 3 squared, which then becomes 1 over 9. Table gives some information about the heights of 80 girls. Okay, draw a box plot. So grab your ruler and read the table. So we can see the least height is 133. So let me get my ruler, make sure I've read the axes. They're all going up by 1 each time. So 133 will be there. Again, pencil and ruler in the exam. That there. The greatest height is 170, which is about there. Actually, I'll be a bit more accurate with that. Try to be as accurate as you can. It's a little bit tricky to use the ruler on the iPad. There we go. The lower quartile is 145, which is right there. The upper quartile is 157. And then it says the median is 151, which is roughly there. And then connect all of that together. So that would be, oh, it's a little bit hard to move the ruler on here, but that's a line through there. And a line through there. And then finally connect this and this. Let me just get rid of the ruler tool now. Awesome. So that's how that looks. Nice, easy 3 marks for that. Work out an estimate for the number of these girls with a height between 133 and 157. So in total, how many girls are there? There's 80. We've been told that all the way up here. Right, so there's 80 girls, and now it's saying work out an estimate for the number of these girls with a height between 133, which is the least height, and then it says 157, which is exactly the upper quartile. Now, a box plot represents all the data, and the upper quartile represents 75% of the data. So, and the lower quartile represents the lower 25% of the data. So in this case, we just do 80 times 0.75 or times 3 over 4. This works the same. And you end up with 60. Question 11. A and B are points on a circle with center O. BC is a tangent to the circle. AOC is a straight line. ABO is x degrees. Find the size of ABC in terms of x. Give your answer in its simplest form. ABO is x. Find the size of ACB. Right, I'm just going to zoom into this because it'll make it a little bit easier to work with. So this angle here, find the size, we'll call it y. They want us to work that out. and ABO. So ABO, I'll draw a line there. This is X. We'll call that X because they've told us that's X there. Awesome. So just with this data alone, there's a few things you'll need to know here. So for example, this, if I get my highlighter tool out, this here, we need to understand what this is doing. So this line here, B to O, is the radius, and that's touching this tangent. Now the radius meets the tangent at 90 degrees. So this angle here is going to be 90, you need to know that. Secondly, this line here is also the radius. This line here is also the radius. That means they both have the exact same length. So that means I can do something like this and this. It's an isosceles triangle, which means both sides are the same and both the base angles are the same. So this is also X. So now we know what them two are. They want us to work out Y. I know this bottom bit is 90 degrees. I need to know what AOC is. So if I just highlight that, ideally I need to know what this is to figure out what Y is, because angles in a triangle add up to 180. So if I look at triangle AOB, so the small triangle, I can work out, if I use a different color, what this is here. So if I draw a line, well, this must be, well, angles in a triangle we know add up to 180. So we know that AOB is going to equal to 180 minus x, and that can be written as 180 just minus 2x. So now I know what that is. I can now use that to figure out what this blue angle will be, because it's on a straight line. So that means BOA is going to equal to 180 minus AOB, which is 180 minus 2x. Put brackets on that. So that then becomes 180 minus 180, which is 0, and then minus and a minus become a plus, so that becomes 2x. So now I know what this is. This is 2x. And then finally, that ties me nicely into, well, what is Y going to be? Well, let me just use the same color that I'm using there. So, well, we know that angles in a triangle add up to 180. So Y is going to be 180, which is the entire triangle, minus the other two sides, which is 2x minus 90. We know that 180 minus 90 is 90, and then minus 2x. That is your answer. And notice here, it says give your answer in its simplest form. So that's kind of a hint that you're not going to end up with a numeric answer, because it's saying in its simplest form because the questions asked you for an angle, but then it said in its simplest form. So that's already a hint to you that it's going to end up being some sort of a fraction or some sort of an algebraic equation, and give reasons for each stage of your working. So I've spoke through the stages of my working here, but you would write something like angle BAO is equal to angle AOB, because the radius meets the tangent at 90 degrees, and then it forms an isosceles triangle, just like I was talking through. And for example, with BOA, which is here, so that's a straight line. Angles on a straight line add up to 180, so we can subtract them two. And then with this one, finally, we can write angles inside a triangle add up to 180. So I've talked through all of it, but yeah, just make sure to write that down as well as you go along. Let me just zoom back out to where I was. That was a really nice question, because it really makes you think. So prove that the square of an odd number is always one more than a multiple of 4. So just to clarify one thing before we do dive into this. So even numbers take this form 2n. So if n, for example, was equal to 1, if I substitute that into there, it becomes 2. If n was 2 and I substitute it into there, it's 4. If n is 3 and I substitute it into there, it's 6. Now notice, always even the answer is, no matter what n is. And for odd numbers, we have this other equation. Well, there's a few ways you can write it, but here's one of them. So you can write 2n minus 1. You could also write 2n plus 1. So if I substitute n into here, the answer is always odd. So when n is 1, the answer is 1. When n is 2, that'll be 2 times 2 minus 1, which is 3. And when n is 3, that'll be 5. So the answer is now always odd. So this is what an odd number looks like in algebra, and that's what an even number looks like in algebra. So now it's saying prove that the square of an odd number, so that's going to be 2n minus 1, square of an odd number, so let's write that out, that's 2n minus 1, 2n minus 1, is always one more than a multiple of 4. Let's expand that. So that's 4n squared minus 2n minus 2n plus 1. So that's 4n squared minus 4n plus 1. So when you get to this stage, now you really want to read the question. What is it saying? The square root of odd number is always one more than a multiple of 4. So let's look at the one more. Yes, we have that. Of a multiple of 4. Well, we can factorize this bit. So that's 4n bracket n minus 1 plus 1. And that's a proof done. So that's a multiple of 4 plus 1. The next one is surds. So let me just change the color back. So that is going to be expanding this bracket out and making sure we are getting it in the form the question's asked for. So we can do 5 times 8. So that's root 40 plus 5 times 18, which is root 90. Now at this point, look at what the question's asked for. It wants it in the form a root 10. So now you need to think, well, how can I write these two surds in the form of something root 10? So I can write this in 4 root 10, and I can write this as 9 root 10. So that becomes 2 root 10 plus 3 root 10, and that becomes 5 root 10. But the question only asked us for what a is, so in this case, a is going to be 5. So y is inversely proportional to d squared. When d is equal to 10, y is equal to 4. D is directly proportional to x squared. When x is equal to 2, d is equal to 24. Find a formula for y in terms of x. Give your answer in its simplest form. So let's work top to bottom. Let's focus on this bit first. So that's saying that y is inversely proportional to d squared. So that's going to be k over d squared. K is the constant of proportionality. So that can now be written as y is equal to k over d squared. Now it's told us when d is 10, y is 4. Let's substitute that in. So y is 4, d is 10. So what is k going to be? Well, k must equal to 4 times 10 squared is equal to k. So we now know k is equal to 400, which means I can write this as y is equal to 400 over d squared. So let me just draw a line down the middle. Now we can focus on this one here. So now it's saying d is directly proportional. So when it's directly proportional, we write it like this, is kx squared. So now we can write d is equal to kx squared. So then it's saying when x is 2, d is 24. Let's substitute that in. So d is 24, x is 2, so we can do k times 2 squared. So that then becomes 24 over 4 is equal to k, which means k is equal to 6. And again, as the last one, we can write this as d 6x squared. Sorry, d is equal to 6x squared. So we've got that equation and we've got this equation. So it says find a formula for y in terms of x. So all that means is we need y is equal to something. So essentially that's what we want to find. So if I write my equations out that I've found, so that's y is equal to 400 over d squared. And the other one I found was d is equal to 6x squared. So it wants it in terms of x. So now if you look at these two formulas, we have y is equal to d squared, and then we have d is equal to 6x squared. So hopefully you can see that we can substitute that into there to get x in there. So that then becomes y is equal to 400, that stays. Underneath it, it's d squared, but we know what d is, 6x squared. And there's still a square on the outside, so don't forget that. So that becomes 400 over 6 times 6 is 36. That becomes x to the power of 4. And it does say give your answer in its simplest form. So if I come back down, so we have 36 and we have 40. So hopefully you've started thinking of the 4 times table. So that's going to be 100 and that's going to be 9. So you can leave that as 100 over 9x to the power of 4. Factorize a squared minus b squared. So it's the difference of two squareds, so that's going to be a minus b and a plus b. And you can expand these out to see how that works. So that's your answer for this one. Factorize just means put it into brackets. Then it says hence, or otherwise simplify fully this equation. Now, the word hence normally means you could probably use what you figured out in part 1 to do part 2. So if you look at this one now, so simplify fully x squared. Okay, so since it's squared, we can write that out like this: x squared plus 4, x squared plus 4 again, minus x squared minus 2, and x squared minus 2 again. Let's expand that out, so that's x to the power of 4 plus 4x squared plus 4x squared plus 16 minus, we're going to leave the bracket here because there's a minus on the outside, so we have x to the power of 4 minus 2x squared minus 2x squared plus 4. And finally, let's tidy this up a bit. Let's expand them brackets out. So we have x to the power of 4 plus 4x squared plus 4x squared plus 16. So that's going to be minus x4. Now the minus and a minus here become a plus. Same here. And here the minus and the plus become a minus. So now we can start to collect like terms. So we have x to the power of 4 minus x to the power of 4. So they can cancel out. We're essentially just minusing one thing from another. If I change color now, we have x squared here, we have an x squared here, we also have an x squared here and here. So we can add these two together and add these two together. So 4 plus 4 is 8, 2 plus 2 is 4. So we have 8 plus 4, which is 12x squared. And finally, we're left with that there and that there. So what's 16 minus 4? That is 12. So plus 12. Moving on to the next one. So it says there are only red, blue, and purple counters in the bag. The ratio of the number of red counters to the number of blue counters is 13 to 7. Sam takes at random a counter from the bag. The probability that the counter is purple is 0.2. Work out the probability that Sam takes a red counter. Remember, probability always adds up to 1 as a decimal, and as a percentage, it's out of 100%. So let's write this bit out. So there's red to blue. So we have red to blue is 3 to 17, and then we have red, blue, and purple. Okay, and we are told the probability that it's purple is 0.2. Well, we know probability adds up to 1, so these two must add up to 0.8. So we can just, for now, we can just call this like x and call this y. So we know that x and y must add up to 0.8. Or 80%, it's the same thing, and this can be written as 20%. So this is 3 and 7 on this side, they add up to 20. If you wanted to go to 100%, we could just write 100 there. Well, how do you go from here to here? You times it by 5, so let's do 3 times 5, that's 15. Let's do 17 times 5, that's 68. So if you now come back over here, we have 15 to 68. And that makes up 80%. And then this must be 20. I'm just having to think there. So the probability that the ratio of the number of red to blue is 33 to 17, which adds up to 20. We take that to 100 because it's out of probability is out of 100. And I'll go down. Yep. Yep. No, I've made a mistake here. It's a good thing I was thinking there. So yes, probability is out of 100, but we know from here it's that red and blue form 80% of it. So the question here isn't going to be how I get to 100, it's how I get to 80, because we know red and blue form 80%. So made a mistake here. There we see times this by 4, times this by 4, times this by 4. So that's 12, and that is 68. So that is going to be 12, 68, and this can be 20. Work out the probability that Sam takes red counter, so that is going to be 12 divided by 100, which is 0.12. Moving on to the next one, so simplify fully, 3x squared minus 8x minus 3. So we have 2x squared minus 6x. So you want to factorize as much as we can, so the bottom becomes 2x bracket x minus 3, and the top is a quadratic, so we can do 3 times minus 3, so 3 times minus 3 is minus 9. What two numbers multiply together to give us minus 9? That add or subtract to give us an 8, so that would be 1 and 9, and to get the minus 8, that must be minus 9 and plus 3, so we can then write that as 3x squared minus 9x plus 1x minus 3, and then that's 3x bracket x minus 3. You can write x minus 3 there, and then we are left with the 1 there, so that's 3x plus 1, and that's x minus 3, so we can then write that as 3x plus 1, x minus 3, cancel that out, and then we are left with 3x plus 1 over 2x. Moving on to question 18, so here is a graph of y is equal to sine x from minus 180 to positive 180. On the grid, sketch a graph of y is equal to x, sine x minus 2. So in the y direction, they're moving it down by 2. So if you look at this point here, for example, move that down by 2, it ends up there. If you then look at this point here, move that down by 2, it ends up here. This point here, move it down by 2, ends up there. Do that for all the points, and then draw a line through it. And that's that done. Moving on to the next one, so point P has the coordinates 3, 4, point Q has the coordinates A, B. A perpendicular line to PQ is given by the equation 3x plus 2y is equal to 7. Find an expression in terms of AB. So some of the things you should have already started thinking at this point is, with perpendicular lines, you can work out the gradient of the lines using a formula called m1 m2 is equal to minus 1. What that's saying is, if you know the gradient of one line, you can divide it by minus 1 to get the gradient of the other line. So perpendicular lines, just as a reminder, are two lines that cross each other at 90. So if that's one line, that means the other line crosses at a 90-degree angle. So the first thing we'll do is write this in the form y is equal to mx plus c. And I'm going to stop using my red pen for now. Y is equal to mx plus c, so that will become 2y is equal to minus 3x plus 7, y is equal to minus 3 over 2x plus 7 over 2. Okay, so now if I draw a rough graph, so I know the x-intercept for this, so that's the y-axis, that's the x-axis, is 3.5 because that's what 7.2 is, so I can draw that there. So that's 3.5. I know it's got a negative gradient, so the line will be going down, so it looks something like so. I know P has the coordinates 3, 4, so let's plot them on. So 3 there, 4 there. Let's use a different color. So that's going to be that there. That can be point P. And since it's passing perpendicular, we can just say Q is probably somewhere there, roughly. And then it must have something that goes like this through it, and that's a 90-degree angle. Okay, so remember the formula I told you earlier. I'm just going to draw a line there. So we have m1, m2 is equal to minus 1. We know the gradient of the green line is minus 3 over 2, so we can write that in this formula. We have minus 3 over 2, m2 is equal to minus 1. So m2 is the blue line, so that means the gradient for the blue line, if you divide each side by minus 3 over 2, you end up with 2 over 3. So that is the gradient of the blue line. So now we know the gradient of the blue line, we can write an equation for the blue line. So that will look something like y is equal to mx plus c, which is 2 over 3 x plus c. Now we know the coordinates for p are 3, 4. If we substitute them in, we can figure out what c is. So that will be y is equal to, well, not y, we know what y is. 4 is equal to 2 over 3, x is 3, plus c. So that means 4 is equal to 2 plus c, and then c is equal to 2. Awesome, now we know what c is, we can write this equation as y is equal to 2 over 3x plus 2. But the question says, find an expression for b in terms of a. So now all we need to do is sub in the coordinates for q, which are a, b. So into this equation, if I move over there, we know y is b, 2/3 x, which is a, plus 2. So that is your final answer. And for the last question on this, n is an integer such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is greater than 1. Find all possible values of n. So let's start with the left-hand side. So we have 3n plus 2 is less than or equal to 14. We can replace the less than or equal to sign with an equals if that helps, and bring it back in at the end. Minus 2 minus 2, 3n is equal to 12. Divide each side by 3. That means n is equal to 4. So that is that done for this side, and we can write n is less than or equal to 4. And you can always test that by substituting a few values in. So if you look back at this expression up here, if you sub in something like, for example, and you could try in a few values, so you could do something like, I usually tend to do one value which is 4, one value which is less than 4, and one value which is more than 4. So if n was 3, that would be 3 times 3. I'm looking at this equation up here. So 3 times 3 is 9, plus 2 is 11. So that means 11 is less than or equal to 14. So that is true, that works. Does 4 work? So we know 4 times 3 is 12, plus 2 is 14. So we have 14. So we have 12. It's less than or equal to 12. 14, that works. And finally, we can sub 5 in. 5 times 3 is 15, plus 2, 17 is less than or equal to 14. That does not work. So that means for this question, we can have any value that is less than 4. And for the now, it'll become a bit more apparent why I did this when I do the next question. So this can be written as 6n over n squared plus 5 is equal to 1, times each side by n squared plus 5, so that means n is equal to n squared plus 5. Now if I rearrange this, we end up with n squared minus 6n plus 5. We can factorize this, two numbers that times together to give us 5, add or subtract to give us minus 6, those are them, so n is equal to 1, or n is equal to 5. So now here the signs become important. So again, I'll do the same as what I did there, so I can list some values out. I'll go 1 below the 1, which is 0. In fact, I'll do it even lower down here, so let me just draw, I've rubbed that off. Let me just draw that line back, because this bit is key. It really confuses some people. So if I continue this question down here, I know n is 1 or n is 5, and like I said, we'll go 1 below, which is 0. So we have 1, 2, 3, 4, and I'll go 1 above, which is 5, which is actually 6 in this case. So let me just do that again. So that's 0, 1, 2, 3, 4, 5, and I've done it again. So let me just move that over. And 6, and you'll see why I'm going into depth on this, because it can really confuse some people. So now if I sub in 0 into the equation that I had, so that's 6n over n squared plus 5, and I can rewrite that. So we can rewrite that as 6n is greater than or equal to n squared plus 5. So now when n is 0, so that means on the left we have 0, is greater than or equal to 5. Is that true? Is 0 greater than or equal to 5? No, that's not true. So that means 0 can't be a value. If I move on, what about when n is 1? So that means we have 6 times 1, which is 6. Is that greater than or equal to 6? Yep, it's equal to it, so we can have that. So I'll put a tick there. What about 2? So 6 times 2 is 12. Is 12 greater than or equal to 2 squared, which is 4, plus 5, which is 9? Yep, that's true. So we can put a tick there. Same with 3. Same with 4. What about 5? I'm just doing this to speed up a little bit. So 6 times 5 is 30. Is 30 greater than or equal to 5 squared plus 5, which is 30? It was greater than, oh no, it was greater than, my bad. It was greater than. Right, so that means, that's fine. is 6 greater than 6? That means we can't have this value here, and that means we can't have this value here either. And if I move on to 6, the number's getting even bigger now, so 6 times 6 is 36. Is that greater than or equal to 36 plus 5, which is 41? And the answer is no. So the accepted values here are these three, and we can sub them into, if you want to make sure, with the other two. So for example, if you sub 3 into here, that'll give you 18 is greater than 3 squared, which is 9, plus 5, which is 14. 18 is greater than 14, and you can do the same with 4. So you can see now these three values are accepted here, whereas this question accepted anything which was less than or equal to 4. So my answer is going to be n is equal to 2, 3, or 4. And those values work for both questions. I hope you found this going through this paper useful.